versus time graphs. So we have this, pause, vote. Correct answer is A, only. They have the same position at the same time. They're located here. Blue started here and went that far. Purple started here and went to that far. So they had different displacements. Okay. Next question. Which object's moving the fastest? Pause. Correct answer is purple. Why? Because it has the steepest slope. Okay, slope communicates the velocity. Okay. Which order do they start in? Which one's closest to the finish line? Pause. Correct answer is B. You can make up some numbers. They all end at 0 at the end zone. This started, I'm making this up, at the 20-yard, 30-yard, and 40-yard. So green starts closest to the end zone. Okay. And then which one has the greatest displacement? Pause. Correct answer is purple has the greatest displacement. It started at the 40 and went to the 0 versus the blue started at the 30 and went to the 0. Why is the blue line longer? It's because it took more time to get there. Okay, it's not the fact that it had greater displacement, it just took a longer period of time. And finally, which is the order they finished in? Pause. They finished, correct answer is D. You can make up some numbers here. 5 seconds, 10 seconds, 15 seconds, 20 seconds, 25 seconds, 25 seconds. 0, 5, 10, 15, 20, 25, 30, 35 seconds. Okay, good to that. This dotted line is talking about just a placeholder, just kind of compare and contrast. Which one's going faster? Pause. Correct answer is orange is going faster. They're just trading positions on the football field. The orange just did this in less time, therefore it's going faster. There you all go. Thumbs up when you have an answer. Have a conversation.
Yeah, I was like, oh my.
Okay, correct answer is C. It has a steep slope and then a shallow slope. All positive slopes though. Okay, this is just like in math class where this is a positive slope and that is a negative slope. Good with that? Corresponds to the direction of travel, direction of velocity. Thumbs up if you have a guess. Talk to your neighbor. So, Lexi, that would be going back in time.
Did you hear me say that?
I did. No, it's good. It's good. I mean, does that make sense?
Kind of.
Like, because you're going to do this.
They're changing positions super fast.
Yeah, because time's always going forward. Does that make, no, it's good. It's good. Does that make sense, though? I mean, I'm always trying to listen. Okay. Heard a lot of good conversations. Let me talk you through this kind of new ground. We're breaking new ground on this one. Okay. We want slopes, any slope that's going in this direction. Okay, because you're moving in the negative direction. Okay, so that knocks out B and D. You okay with that? Process of elimination here. Now, if you ever have curves on a position versus time graph, I would highly recommend breaking it up, breaking the graph up into chunks. What do I mean by that? Breaking it up, that chunk, this chunk. This chunk here, does it have a positive or negative slope? Negative. Is it a steep or shallow slope? Shallow, which corresponds with fast or slow? Slow. This, positive or negative slope? Negative. Steep or shallow? Steep. Fast or slow? Fast. So then we put the story together. We connect the dots. We start slow in the negative direction and we get faster in the negative direction. Here, negative or positive? Negative. Steep or shallow? So, yeah, steep or shallow? Steep. Fast or slow? Fast. Still negative. Fast or slow? Slow. Start fast, slow down in the negative direction. See how we're doing that? If you just learned something, capture that. Okay. This would just be moving at a constant rate in the negative direction. Okay. Good there? Thumbs up when you have a guess. Have a conversation. Tell them why.
And then they use it's really like steep at first.
Correct answer is E. Everybody good with that? You want a positive slope, so it needs to be tending this way. This starts steep, so fast, and this ends up shallow, so slow. Starts fast and slows down in the positive direction. Thumbs up when you have a guess. Let your people know.
Is this recycling?
Yep, in the blue. Okay. What do you say? The most. D is correct. So taking this in chunks. Positive or negative? Negative. Fast or slow? Positive or negative? Fast or slow? Positive or negative? Fast or slow? In order to go from negative direction to positive direction, there has to be a point. So you're walking the negative direction. At some point, you got to turn around. At some point, you got to stop and turn around. That could happen quickly or slowly, but at some point, that turnaround. Where is the turnaround point? At the minimum. Where the slope, the instantaneous slope or the tangent line is 0 right at that point. And then you speed back up. Okay? B would look something like that. Good there? Thumbs up when you have a guess. Tell your neighbor. Correct answer is touchdown. How we doing? Okay. We're not done. Okay. Shifting gears a little bit, we're going to look at velocity versus time graphs. So by the end of this lesson, you will be able to describe the motion depicted by a velocity versus time graph. You'll also be able to create a velocity versus time graph from description of motion and position versus time graph. Okay, let me give you, so this is a velocity versus time graph, not a position. A hint is this is what is telling what happens to your speedometer, or what your speedometer says. Okay. At the 2-second point, your speedometer says 0 meters a second, meaning that you're stopped. Where are you stopped? You have no idea. You could be stopped anywhere. Does that make sense? So this is communicating your velocity, not your position. Okay, good with that? So we're shifting gears a little bit. Thumbs up when you have a guess. Okay, this problem proves to be taxing. So rather than having you guys talk amongst yourselves and confusing yourselves more, I'm just going to tell you. So at 3 seconds, at this clock reading, you're moving 2 meters a second. A is true. And only A is true. The rest of the stuff, can't conclude that. How? Here's an example. Let's say you're driving, you're merging onto I-65. So you're on the entrance ramp. At some point, your speedometer passes by 50 miles an hour. You okay with that? Like it doesn't just stay there. Like you're continuing to speed up, but at some point it passes by, boom, 50 miles an hour. Does that mean you've traveled 50 miles? No. That just means your rate is 50 miles per hour. If you would maintain that rate for an entire hour, then you would have traveled 50 miles. But your speedometer, you're just traveling at that rate for that moment in time. All this tells you is your speedometer is going 2 meters a second at that moment in time. The only way you're going to travel 2 meters is if you traveled at that rate for an entire 1 Mississippi. If you traveled at 2 meters a second for an entire second, then you would have traveled 2 meters. You see the difference? Does that make sense? How that's doesn't tell you how far you went unless you know how long you went that speed. How are we doing with that? Questions? Points of confusion. I'm totally fine with you just going, don't get it. Try that again. Yeah. Thumbs up when you have a guess. Tell your neighbor. Tell them why. Correct answer is? Correct answer is C. Okay? This is not a position versus time graph. If this is position versus time graph, A would be true. You're moving, you're not moving, you're standing still if the line was here at the 0 meters a second. It's not 0. It's below the x-axis, so we're negative values. Okay? Let me give you a tour of a velocity versus time graph. I would highly recommend making up numbers if you're like, it hurts my brain. So positive 1 meter a second, positive 2 meters a second, positive 3 meters a second. Okay. If you are above the x-axis, this is positive land. You're moving in the positive direction. Is that legible from way back there? Oof. That's kind of brutal. Okay, you're moving in a positive direction. Below the x-axis, negative 1 meter a second, negative 2 meters a second, negative 3 meters a second. Okay. If you're below the x-axis, then you're in negative land. And you're moving in the negative direction. Does that make sense? Where that comes from, why that is the way it is. Weird, kind of, maybe not intuitive, but can you swallow that? All right. Now, most people do not have a problem with this next statement. As you go away from 0, your speedometer is getting higher. You're getting faster. Most people have no problem with that. This next thing, this is where it takes your brain and goes, and you're like, what? As you progress this way, what happens to your speed? Gets faster. You're just getting faster in the negative direction. So as you go away from 0, you're getting faster. As you go towards 0, you're getting slower. This right here, this is weird. This breaks people's brains for a little bit until you digest it. Okay, totally get it. It's not intuitive. We're going to spend some time crunching through this. Okay. Relative scale. Thumbs up when you have a guess. Have a conversation.
Yeah, and then E is too fast. Yeah,
Correct answer is? Correct answer is D, as in delicious donuts. Okay. B would be correct if it was a position versus time graph. Okay, but it's a velocity versus time graph. Okay. Here you have a constant but slow speed relative to this. This is faster. Okay. Thumbs up when you have a guess. Talk. Tell them why. What do you say? Here we go, C. Okay, we're moving away from 0 as time goes on. It's getting faster and faster in the negative direction. in your brain. Don't influence or be influenced. So disengage your mouth. How many more what? A couple. Tell your neighbor. What do you think? The answer is A. D also shows speeding up in the positive direction, but not at a constant rate. That makes sense? Okay.
Why isn't like C?
Great question. So C starts fast in the negative and slows down. This part,
Oh, it's not the same.
nope. Does that make like this? The second part, yes, but this first part, no.
Will that ever be like a thing? Will that ever exist?
C?
Yeah.
Oh yeah. Thumbs up when you have a guess. This might be a good conversation. Talk to your neighbor.
No, it's B. Also, I think it's in the negative route. Yeah, I know. No, because. No, it's B. Yeah. So what happens if the low closer to zero? I just saw that. Oh, it's going to. I noticed when you do, and I was like, huh. And I realized that slope is positive. Yeah. I would have gotten it.
All right, what's our conclusion? Okay, I heard B and E. Are there any other letters we want to throw in the mix? A? Okay. I agree. B and E show you slowing down. Both show slowing down. But E is you traveling in the negative direction. B and E both show the graph going towards zero. But E shows you, okay, Here's a suggestion when you're reading velocity versus time graphs. Make up numbers. Okay? Let's like 0, -1, -2. At this point, you're not moving. At this moment in time, how fast you going? 1. In which direction? Negative direction. Here, you're going 2 in the negative direction. Put it together, you're speeding up in the negative direction. Here, you start going 2 meters a second in the positive or negative direction. Positive. 1 meter a second, positive direction, 0. Give me a number. -2, -3, whatever. -1, 0. You're slowing down in the negative direction. Okay? If you learn something, if your mind got changed, write that down. We're going to stop there. Excellent question. Okay, so B is also tempting because it has a negative slope. Okay, if this was position versus time, that would show a negative velocity. But what shows the sign for a velocity versus time graph is if you're above the x-axis, you're in positive land. If you're below, you're in negative land. You go in a negative direction. Not yet. Next chapter. Okay, you got homework that's due Monday. You know how to do most of it. Like you could definitely give that a shot. Around the corner. Yeah.
I was right.
You're digressing.
Yep. I heard it on the walk on.
Yeah, I bet. I was like, it just blew my mind that they didn't.
I know.
It's like, here's a brace.
I really feel like if I walk on it a month, I'd go to get a checkup with him. Like,
Yeah, I don't know. That's wild. I've never heard of that before. Yep, you can take off. All right.